trend that we saw? Anyone? Brendan, what did you say? What did you say for the trend that you predicted?
I said that it would increase. Pressure, yeah, the pressure will increase.
Okay. As temperature goes up?
Yeah.
Yeah. Everyone basically find that? Okay. So that's Charles' law is going to be looking at the relationship between pressure and temperature, and basically for the last question you should have said that as the molecules sped up, they're going to be colliding with each other more, so the pressure is going to increase. So before we do anything else, Kyle, can you come up here?
I'm Kyle.
Yeah, you can come up too.
Yay.
Okay. Kyle, I want you to stand here. We have this line that's at 0, and Kyle is going to measure Kyle. So from the 0 line, how many inches is he? Okay, Kyle is 10 inches. And Kyle, what is your actual height?
Like 5'11".
That's like 71 inches?
Yeah.
71 inches. Okay. Actually, Kyle, you have to stand here. So now, just measure me.
Like 4.5.
Okay. So I am 4.5 inches. Now I want you guys to all figure out my actual height. The missing variable is x.
You're not 31.
Is that what people are getting? 31 inches?
Yeah.
Okay.
Hey,
So,
wait, don't tell me that.
so Jake, what you missed is we measured Kyle from this line. He was 10 inches. His actual height is 71 inches. So then they measured me. I'm 4.5 inches from that line. Then you had to figure out what my actual height is. So what is 31 inches in feet? About 2.5.
Yeah. You're 2.5 feet.
So here, my 31 inches works out to about 2.5 feet. Am I actually 2.5 feet tall?
Possibly. Give or take 2 people and 4 feet.
Give or take 4 feet. So, give or take 4 feet. Yeah, that's right. But why is it coming out that I am only 2.5 feet tall? What's the problem?
Because we don't know how tall the thing is.
Oh, yeah.
You don't know how
Oh,
tall
we didn't.
the thing is.
Yeah. Cody, good job.
Yeah.
I remember doing this. We've done
High five on that one. Yeah.
So, the problem is that this line that says 0 on it,
Isn't really 0.
it's not really 0. So with the reason why I'm doing this is for these problems, is Celsius really at 0?
No.
Like 0 Celsius.
It's 273 Kelvin.
Exactly. 0 Celsius is 273 Kelvin. So
Wait for me down.
absolute 0, which is the absolute lowest temperature that you can actually get to, is 0 degrees Kelvin.
Is there actually that? Like, can there be a point where it doesn't get colder?
it doesn't get colder than absolute zero.
What's absolute zero Fahrenheit?
What is
Well, put Fahrenheit into Celsius and then
Yeah.
take away 273.
I don't like doing Fahrenheit to Celsius.
She doesn't know, she doesn't know, she doesn't know.
My education professor's gonna like that. Okay. So absolute zero is at 0 degrees Kelvin. 0 degrees Celsius is at 273. So you saw that when you're not actually at zero, you can't do the right calculations. So the reason why I'm telling you this is in Charles' law, anytime that you do any sort of calculations, you have to make sure that it's in Kelvin. Otherwise, your answer is not going to come out right. So taking notes on the back of the worksheet that I just gave you, I want you to write down the absolute zero is at 0 degrees Kelvin. 0 degrees Celsius is at 273. And then Charles' law
Wait, what's 0 degrees Celsius?
is V1, T2 equals V2, T1. And there, V is our volume. So we have initial volume, final volume, initial temperature, and final temperature. So the definition for Charles' law is the volume of fixed mass of gas is directly proportional to its Kelvin. Make sure it's in Kelvin. Temperature if pressure is the same. These problems are going to be pretty similar to Boyle's law, where you're just working with temperature rather than pressure, but I'm going to work through one with you guys before I give you the handout. So we could say our initial volume is 500 milliliters. And our initial temperature is 30 degrees Celsius. Then the temperature goes up to, let's say 50 degrees Celsius. So then we know, based on that, that what we're looking for is the final volume. So what do we have to do before we plug it into the equation? Yeah, put it to Kelvin. So add 273. Then we have 303. Add 273. So then after that, we put it in into our V1 T2 equals V2 T1. And I'm just going to label these. So we have initial volume, V1, initial temp is T1, final temp is T2, And final volume is V2. So on one side we have V1, 500 mils, times our T2. Notice it's T2, not T1, which is 323. And that's equal to our V2 is X and T1, which is 303. So what do we do to get X by itself? Yeah. So bring the 303 over here and divide it. So if you divide it on this side, you're left with X, and that's equal to this calculation. And what would our units be for X? This is Kelvin, this is Kelvin, yeah. And it'd just be in milliliters. I'm giving you guys a worksheet to do on these problems.
Yeah, I know.
That's why I wanted to go into teaching, was so that I could kill trees.
I like killing trees.
Yeah.
Oh, as if.
Here's a picture of
You
you
lucky.
Which side are we on?
I don't know, man. Just
Charles,
little worksheet.
I'm not a tree hater.
Hey, which one
I
are we
love
on?
trees.
Combined gas.
No, you're working on the Charles law side.
Oh. Hey,
Sorry, I hole punched it on the wrong side.
you did.
That's okay. When we do this side, then we'll be on the right side.
Yeah, exactly.
No.
That was my intention.
Take it here.
Whole bunch upside down.
That's a cool review.
Yes.
This person should just figure it out for themselves.
From the wrong problems.
What's validation from? Huh? What was validation from?
She's like 3 meals a day.
Hey, we do. That's what she always wants.
So before you do anything else, it's helpful to just label what your V1, your T1, your T2, and your V2 are.
Doesn't matter who it would be wait, what? V1, T2,
Yeah. Oh.
Yeah. Yeah.
Yeah.
Why would we need a balloon in an oven? That's just not smart. If it's solving this problem by not putting a balloon in the oven, that'd be great.
They were just curious about what would happen, Kyle.
Balloons pop when they get hot, you know.
They wanted to see it pop.
So the balloon's gonna pop and there's not gonna be anything left in there. This is a trick question. I ain't answering that one. I refuse.
What else do you have to do to They're in Celsius. Okay. But now you have the formula set up, right? So you just have to add what else is on this side? The 277 played with before. Scored plus 273 is 277. And then our other temperature is 22. It's in Celsius. And what do you want? Yeah. 22. What are you still missing? Second volume is what you're looking for. So let me here. So this is your x. So if you have x times 295, you do all of this. How do you get x by itself? Divide
Why would you make
this
hell yes?
by
You're doing it right now.
Oh, Jay.
Okay.
That's buddy. That's nice.
So all of this stuff is on this
Get it?
side.
Like a fart.
Like, yeah, it's good.
Times 25.
Who came up with this stuff?
And then divide it on this. That's the answer. In what unit? So you've done two temperatures. This was liters.
clean version now. It's way ahead. I don't know how to do this.
This one, if you look at 400 is your final volume, right?
Okay, how do I do it?
But this is the first video, so E2 goes with temperature 1. So what's the initial temperature?
Oh, okay. Oh, that's
You
right.
had it set up here.
Yeah, I see. Yeah, I see.
Yeah, so you just switch the side by next to it. Yeah. Yeah.
First, which is second, I don't know.
Usually it says one of them is initial. So like, see here, this says initially the volume.
Well, I know, but the thing with this is that that one. Because you don't leave the car.
This is your
That's the fun.
yeah.
So.
So because you know that this volume goes with this temperature, and this is the initial volume. So if
Oh,
that's
okay.
the initial volume, this is going to be the initial temperature.
But it's gonna be one by T2, right?
Yeah. So this is your V1. This is your T2. You do that times that, but you have to make sure you do it. Equals your X and then X. After you convert it to don't worry about those.
Very good about it.
Yes.
Would it be like -4? Plus what? 260.
That's why I'm going to.
Yeah. I did that.
Okay, that's good. So now, what do you have to do to those temperatures? They're in Celsius. What order are we changing them to? From Celsius?
Cal.
So add 273 to each of those.
That's the most recent.
She's a big thing of emotion.
German ship.
I guess the point, that's why I said that.
273.
That's what you got. Yeah. Yeah. So those are right. And then the equation is V1 T2 equals V2 T1. So V1 is 0.5. So we're at 0.5
German ship.
times your
My
T2.
face off.
That's the 295. Actually, 295 because initially has a temperature of 22. So this is actually your T1, and this is your T2.
This is something to listen to.
This one's better
Are you
than
really
last
playing baseball?
one. Yeah. And then equals
Are you really
X
thinking more
times 295.
Oh, okay. Did Jake live what?
Hey.
Equals
So excited.
X times 295.
He's thinking about it. He is. He's just
No,
like,
I would play before. You play
So how do you get X by itself?
Look at
I
it
think
like
those are like,
that. I guess he does. I guess he
Yeah.
calls us.
And
I
he's
guess
still
she's
has
gonna get some
He still didn't deny it.
You want help walking through one? You mix the temperatures. It says initially has a temperature of 22. So this is actually your T1, and this is your T2. So you want to multiply that by 277.
No.
And then what's on the other side? Yeah.
This is the best one.
T1 times T2. Because this is the 0.5 is your V1. You're looking for V2. So you write it out. Say equals X times 277 or 295. How do you get X by itself?
Too late. I already ate the chemicals. So my first two is.
Yeah.
She didn't put her hair in a ponytail.
Yeah.
Hey, what happens if you eat a lot of salt?
Big
I
bag.
I heard that if you eat a lot of salt, you
So,
die.
Probably throw distillation water in the body.
okay, so
You want to use the
I was just
It
gonna
was made by Charles Darwin, right?
Yeah.
Evolution, is that Charles Darwin?
I was gonna just
You had a lot of
give you some something that I think.
a lot of salt.
I think that if I wonder what that means. That's great.
It's point one out. Yeah.
G, okay. I this
No,
was
I
so
mean,
fun.
no, I'm not saying go. It's not all of it. It's good though. No, I tried my own and then you didn't.
Okay, well, I.
That's what I meant.
This is.
I know.
If you knew.
I can't figure out why. Did we get the third one right?
Yeah. Put the salt in my food.
Did we get the fourth one right? Okay. You got the first one right.
Let's find out.
You guys are really mixing up.
I'll wait a week and I'll.
Oh, like here?
How do you know if it's,
Because like, I think what you guys are doing is you are V1 equals V2 V2, but it's not V1 V2 equals
Whoops.
in this problem. Initially, the temperature is
if you want to go
so
on.
that's your T1.
So we just switch the temperatures. It should be.
Wow, let my mom.
Try it reversing.
No, we can't get moved on all the way.
Oh, you don't have it all? Are they good?
I don't know, man.
I'm not too good at stuff. I might be buying.
Okay, so you got this one right, so if you work through this
It's
one.
not passing me.
Well, let's see what the car.
Just saying.
You had
So what's that?
the temperatures in Kelvin. There was two temperatures in Kelvin. You had one volume that was in liters. So you're finding a volume. If you're finding a volume,
I
you're
want to
finding
do it, but I have to do it, but I don't know.
Let's go. Made it through those two.
Yeah.
Yeah, so why can't you do the rest of them?
Because this one's impossible, you can't put a balloon in the oven. I don't know what this one's. I can't understand.
Okay, well, let's figure out what our different
We don't.
variables are.
He told me to, he's like, I hate you.
Here's the volume. Here's the temperature. Let's call this our V1.
Oh, so this is, okay, wait a minute, wait.
Well, yes, I know.
So start. know how to do it. No, you do know how to do it. Redo this one. Your 293, your 553. Can you do it?
Well, that's really
Whatever
something. I know.
So then,
It's just like
yeah,
You
guys
want
want
to
to
right?
Nick's home, so we'll do these last two. I want to be able to bench 200.
You mean the number 6?
You could bench.
That's great. Yeah, sometimes big numbers.
I dropped 190 last time. Or not 190 last time. Last year, I dropped.
I can bench a lot.
Yeah. What happened?
Yeah, Turtle was really good.
I was, yeah,
Like if you were like you did anything to him, he was happy to help you, right?
I probably would have.
You guys are fine.
Yeah, sorry.
Take away music.
I just had to show this awesome song.
Okay, but this one is 2 B's, so we just.
Hey, that is not a good work team.
But it's
There's 2 B's. How many temperatures are there? Yeah, so you're
he
looking
does.
for
Everybody
temperature.
needs it. No, I'm
So
saying.
just make sure that you figure out which temperature
He
you're looking
thinks you
for.
already hit.
This is.
Why? Because you got all mad in the gym when
Mhm.
he's from your hand.
But what does
Just-
D2 go
I
with?
just hated that.
View.
I know.
So.
He was 100% catching this year.
Yeah.
Was.
Dude,
You said just I didn't drop a ball. Didn't catch one, but I didn't. No. Basically,
Keep working on
no, it's.
Oh, Jake.
Mistaking, Jake. What?
All right.
Yep, that's right.
How much you got?
What's 273 plus 38? Quick, someone tell me.
What did you say?
273 plus 38. Okay, I read. Thank you. Okay, get your chance today. 273 plus 18. Hurry. Hey, where are you? You just missed your shot again. You just missed your shot. 691.
You did one.
I never did
and
shot.
another.
You would the first time. Always carry that stuff around.
Chapstick?
Good shot.
So what's happens like once every 5,000.
Once every 5,000 years.
I actually did
No longer you told.
I actually-
First time in his life.
I actually did get it once.
And then you're like,
No.
It made my like whole nose and lips.
So next,
I look like a
we could do faster. So you know what you're
Take
doing.
your
You
time.
just do that one.
Was that the first practice?
Take your time. It's not about how fast you can do it, but if you can.
Fleur, was that the first practice?
I'll take 30 minutes for this next question.
Dude, that was awful. My fingers were purple.
You know how to
Like me and Mason one side yeah, purple.
I went inside too, guys.
I went inside and I sat in there for like half an hour.
I think it's still full.
Yeah.
By the way, I couldn't even hold up this thing anymore. I couldn't do it.
Yeah, your knees not even wrong.
Oh, right
I
inside.
would be music. Yeah.
Living La Vida Loca. Do you remember that song?
Ricky Martin.
That was big in my day.
Mine too.
Yeah. One of my first CDs was Ricky Martin, and I remember it was a Christmas. I got Ricky Martin and Britney Spears. The Oops, I Did It Again album, so good.
Wait, are you
Oh, I remember that song.
Are you 21?
Hey, that I looked real
22.
quick at that guy. He was trying to hey, know who he looks like? Matt, look for him.
Wow,
You
thanks.
see it?
Thanks a lot. Really. What do you think about me? Pretty hot. You must think I'm ancient. My hair turning white yet?
My brother's
Tell me that doesn't look like your That looks exactly like your
No,
I think it does. That looked real quick. I thought it was when I flipped it. I was like, what?
I can't wait.
Exciting.
I'm getting like,
I don't listen to songs because I mix up on the chairs.
Yeah.
That guy's
That's
hot.
right.
Matt Clifton.
And this one,
That's what she
I
said.
heard the tea. When they were dating, I saw.
I think you did that with Black Brothers.
I remember that too.
yeah.
Yeah,
I thought it was like
you
one
might have to reverse
That's
that.
just like,
Not that one.
yeah.
The rest of it.
Sure. I'm sure this person has a list of people. Be like, are you here? Are you here?
No, ushers ran to their seat.
Usher's the singer.
Yes.
Oh, I got this. I need you such a good piece.
No, that's just it's fixing his hat.
I think you might have mixed up the temperatures.
Or no, not 273.
400
No, 25 plus 7.
Don't say anything. Don't say anything.
98.
Oh, 98. I got it right. I got it right. I said it.
King? No,
Oh, yeah.
Was the 250 your temperature? That's the volume.
Now,
Yeah.
say.
I don't have one right now.
Should be. Push.
So is it 344?
You want to really find you.
Okay.
Just
100.
So you always want to start. Just write it up here.
That's right. Beat that woman.
I don't think that's right.
Okay, so.
Hey.
Yeah, so you should have done 19 plus 273.
You want to plug in all those other numbers where they go
Ew.
there.
Gross hair off.
290.
Ratchet hair. I don't think this is right. There's something wrong with this equation here. There's something wrong with this here.
Oh,
285. That sounds better.
yeah, that sounds good. So, here's the first.
Oh, that's the first one?
No, that's our second.
Okay.
So, E2, so you have that on the right side. The problem is that your initial temperature is 25, and initial temperature goes with second volume.
Oh, come
We have
on.
298 here, and that's your X.
Oh, Miss Mertzel.
Hey, listen to this. At Geiger, one of the fourth grade students, the last name's Fournier, and she writes her name for N-I-E-R.
You're mean today.
No, Miss Mertzel, I saw on this like scientist website that they look at state of matter or something like that. It's like crystal and liquid at the same time. Crystal meth?
No.
Is it crystal? Oh, I'm serious. It's found in chicken eyes.
Chicken eyes? Only chicken eyes?
Chicken eyes.
What if it's in our eyes?
You know how many eyes you have? Whatever. Physicists.
Why would they even look there? Hey, I'm gonna find new matter. Let's look at your chicken eye.
Alright, we're good.
You just poked my eye out.
I'm gonna give you guys a couple more minutes on these problems.
Give me a second.
51,000.
That's why I said I'd give you a couple
That's
more
what I
minutes.
thought.
You said 10.
120 seconds.
120 seconds.
Alright, I'm putting it down.
Countdown.
Down.
Shut up, Flynn. Stop doubting.
He's right.
That's fine. It popped before then. That problem's not even acceptable.
Material is like crystal liquid.
Oh, you ratchet.
Are you sensitive for it? Yeah, sorry.
That's perfect.
Don't call him that, okay? He's my friend. He gets sensitive.
So your name's Bouncy.
Oh, no!
Okay, guys, I'm gonna go over these.
Has not been 120 seconds. I was like 46.
46. You're counting? Okay, I'll give you 64.
No, he's actually counting.
74.
He's actually counting. 6. I hear him.
Didn't you say 46?
Yeah. It's an idiot. Come on, dude. Get together. Oh, come on. Quick flip 100 plus 273. Quick.
373.
Oh, come on. Chloe answered it before you did.
Quick, 25 seconds.
Are you really counting?
Done. He's done. We can start early. No, we still got another 20 seconds. Sorry. Come on.
Okay, so if you haven't quite finished, I can help you out with these problems if you want. I'm gonna go through one of the bottom ones,
even
either
answer
6
two.
or 7.
Don't even answer 2.
Don't answer 2.
Don't answer number 2.
Can you plug your ears while I say the answer?
No, because you can't put the
10.
It's a trick question.
No,
Okay, the first
You don't put
answer
balloon in the oven.
was 0.469 liters. Second answer was 0.71 liters. Third one was 285.1 milliliters.
Yeah.
The fourth one was 1.8 liters. Fifth one was 2.35 liters. The sixth one was 51,826
Yeah, screwed up on the
liters.
bottom part.
Or not liters, sorry,
I
Kelvin.
screwed up.
And 7 was 279.75 Kelvin. Do you guys have a preference on if I go over 6 or 7?
Actually, those are both the easiest.
I'm gonna go over 6 for you guys.
Not 2. You don't have to do 2.
So, first thing that I do is identify what each of my variables were. So write out T1, T2, and V1, and V2. So it says, how hot will a 2.3 liter balloon have to expand to a volume of 400 liters? So there I'm given my initial volume and my final volume. Initial volume is 2.3 liters. Final volume is 400 liters.
I screwed up.
The next sentence tells me that the initial temperature is 25 degrees. What do I do to my 25? In Celsius. What do I need to do to it? Change it to Kelvin. Add 273. 298 Kelvin. So then my formula was G2 B1 equals T1 B2. So I plug in my T2 is my X. I have to multiply it by B1. B1 is 2.3. My T1 is 298. And my B2 is 400. So to get X by itself, I have to divide by 2.3 liters. And then that gives me my 51,826. And the units is in Kelvin because this is in liters, this is in liters. I'm left with Kelvin. So on Monday, you're going to have a quiz that covers just Boyle's law and Charles' law. On Tuesday. Yes.
Thursday?
Tuesday.
Saturday?
Tuesday.
Wait, Tuesday?
Tuesday. So you're going to need to have the two equations memorized. The V1 P1 equals V1 P2 or V2 P2. And this one for Charles' law. I'll write up Boyle's is P1 B1 equals P2 B2. So make sure that you know both of those for the quiz. The next thing we're going to do is the combined gas law. And on the back of the worksheet that I gave you is combined gas law problems. But before you start working on the problems, I'm going to give you guys some notes so you can take those notes along with the notes that you're taking on the Charles law.
So hopefully they don't pick enough notes for this class.
That's why I thought I'd give you more.
Yay, no homework.
Did I say that?
72?
Well, if we have a quiz, I think that means that we should be able to study.
Yeah, you can study.
Right
the
now?
worksheet that I'm going to give you.
Oh my,
Do you need to say that there's no homework?
Okay, so this is the combined gas law.
Jeez, bro, my hand hurts.
And the combined gas law, kind of like what it sounds, combines both Charles and Boyle's law.
Oh, that's gonna be
Combines Charles and Boyle's law and temperature, pressure, relationship into one equation. The equation is E1 B1 T2 equals E2 B2 T1.
I feel like we're in Star Wars.
So the same as with Charles' law, with temperature, you have to make sure that you convert convert it to Kelvin first. So it's very similar, but you're just going to end up having 5 different numbers you have to work with and 1 variable to find, rather than only having 3 variables and 1 that you have to find. So I'll work through a practice problem with you guys. So let's say our initial pressure is 500 atmospheres. We'll say our initial volume is 200 liters. Our initial temperature is going to be 0 degrees Celsius, and the temperature is going to go up to 100 degrees Celsius, and the volume is going to go up to 500 liters. What do we need to find here?
The second temperature. Oh no, I'm
P2.
the second pressure.
P2.
So P2 is our X. So in the formula, we have P1, B1, B2 equals E2, B2, T1. So if we put the numbers in, we have 500 times 200. And what do we have to do with the temperatures? They're in Celsius.
Oh yeah, put the Kelvin.
Put on the Kelvin. So this is actually 273. This is 373. So multiply that by 273. And then all of that is equal to, put it on this side of the board, equal to our P2, which is our X. And our second volume is 500. And our second, this is wrong. We wanted T1 on this side, which was 373. And on this side, we have our 273. So then how do we get X by itself?
What was the question?
How do we get X by itself?
Divided by 270.
What else is on this side?
Oh, 500 out.
500 out, so you gotta
Multiply and divide.
Multiply them and then divide them. So
What happened to it? I just left it at
divide all of this by 500 times 273. But what's important is that you make sure you put the parentheses around this 500 times 273